accelerates.
That sounds, yeah. Go ahead and read what you've got there.
Oh, it just moved on me. Solar sails or photon sails are a form of spacecraft propulsion using the radiation pressure of a combination of light and high-speed ejected gases from a star to push large ultra-thin mirrors to high speeds.
So they're talking about using the force of light on a very, very large sail, because if you're in outer space, then you don't have that problem of air slowing you down, and the force would push, even though, you know, the force on a 1 square mile sail is probably only going to be infinitesimal. It's going to be very, very tiny, but it acts continuously for a long, 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 long time.
And you're never slowing down.
Yeah, and there's no retarding force, so your net force is in the direction of motion,
The only thing
and you
is-
can ultimately end up with huge velocities with very, very little in the way of fuel. So the problem is getting in outer space, get away from atmosphere in the first place, and have a big sail, but you know, it's kind of like the old sailing ships, but using light as your wind.
And yeah, there's only two problems with that. You can only go in one direction, away from the sun, or the whatever star you're at. And then I guess if you built up enough velocity in the solar system, that you'd still have the velocity to go traveling away from the sun. But if you got far enough away and you didn't have enough velocity to start with, like if you're trying to start at Pluto, you might not be able to go very far because like your light is less intense, your solar winds are dying
Depends
down.
on the area of your sail.
Yeah.
As far as the direction part, you can do other directions. It's like a wind sail. The angle of the light on the sail, the force acts perpendicular to the surface of the sail, so you can adjust your sail angle and tack as well. All right, so going back to your seats. And let's take this discussion
Like,
a little bit apart.
you'd think if she got away from school once a week that she would.
The
But,
next
alright.
are the next generation of sailors.
So the fact that the radiometer behaves differently if you have a vacuum on the inside kind of lends evidence to the idea that light then is waves. Because if it were particles, then it would behave very much the way we see it here all the time, but we were getting that effect because our particles were air molecules that were acting inside there as well. So a question then comes up, well, if we think that light actually might have some wave characteristics, you guys studied wave characteristics in Physics 1. Do you guys remember the difference between a longitudinal wave and a transverse? Thank you, I forgot my word. Longitudinal and transverse waves, what's the difference?
The force and the movement go in the same direction. Wait.
The wave and the medium
go in the same direction.
go in the same direction, and the wave and the medium going opposite.
Yeah.
It's hard to do.
Those are transverse waves. Those are longitudinal waves. Okay? So I wonder what light might be if light is a wave.
Haven't they pretty well figured out that it's longitudinal?
Well, let's find out. Oh, by the way, send somebody from each group up. Get one of these for everybody in your group. Send somebody else from your group back here to get these. How many are at your table?
Is this good? I think like this. I can't get it.
Hola. You touched it last.
4.
This table will have extra then. You need 2 of those things that I just gave you. So I gave each table a bag. Inside there are a bunch of little lenses. Okay? Everybody needs 2 of them. There should be enough. Didn't I just give you guys a bag? I had 4 bags.
Are they all the same, Mr. Buckingham? So it doesn't really matter? Or
Yeah, they are the same.
And do we need 2 bags or 1 bag?
You just need 1 bag per table.
Okay.
Because I had about 8 lenses in each bag, and so if we had 4 people per table, then that would give everybody 2 lenses. So everybody needs 2 lenses. All right. So take 1 lens. And by the way, these lenses are polarizing lenses. If you look at the window or something with them, you can tell that when you look through the lens, it's a little bit darker. So what does that tell you about the lens and the light that hits it?
It's absorbing some of it?
It's absorbing some of the light. So some of the light that hits this thing is being absorbed. And we're just going to go through and make several observations. And in this one, it kind of helps to make them in a defined order. And we're just going to run through the sheet. So the first thing, take your lens, look around the room with it, rotate it, through 180 degrees as you look around. Make note of any changes you see in the intensity.
If you put three together or more together, should that make it darker?
We're not doing that right now. That's why I said at the very beginning, it kind of makes a difference the order that you make your observations.
That is cool. Look at the computer screen.
Ooh, that is cool. Very observant of you.
I'm not seeing a difference about the screen.
What's the matter if you turn
I
it?
agree, no difference on the screen either.
Why turn it?
It does have an effect, it seems.
All right, record your observations under step 1. What happens to the intensity of the light as you rotate the filter?
When you mean like rotate, you mean like what
Yeah, just take it.
sides?
Just turn it like a steering wheel as you're looking around.
Oh, okay.
Any differences? You can't have anything nice.
Mr. Verdon, I don't have a bent.
All you need is the plastic piece. If the little rim isn't attached, then it still works. It'll be fine. Just use the plastic piece.
So this is supposed to be bending it?
All right, everybody got your observations made and recorded? You've got your observations made and recorded under question number 1 on your data sheet?
Sure.
So what did you guys notice?
No change.
No change?
Pretty much.
Change.
Pretty much no change, except where did you see change?
On the screen.
Okay. These guys over here, you guys probably couldn't tell because the way the screen is pointed. The computer screen seemed to change when they were looking at it.
The phone screen did
The
too.
light, yeah, the lights, you look at the lights, seem to change.
If you take,
Okay. Yeah.
if you take 2 and mine.
No, we're not doing 2 yet.
Oh, we're not doing 2.
It seems like,
That's why your order of observations kind of makes a difference here. You guys keep jumping ahead, trying to learn stuff. You think this is school. Go ahead.
So I don't know if this is really intensity, except you could consider it acceleration. Is like, what you say, rotate it. As you do that, like it seemed like, well, if you just hold it up to the light, that makes it less intense. And then if you like rotate it fast enough during the light, and then move it quick enough that it will like momentarily in your eyes like bend the light, so it's like the straight light becomes like a curve.
Okay. Zach, did you have something there too?
Whenever you're looking at the light coming through the window, if you rotate it, the actual the glare will rotate as well.
Okay. One of them that I noticed, and I don't know if you guys see the light source on table group 2's table over here. I noticed when I was rotating it, the top on that one really changed, but it may be just from my angle. Do you guys pick up on that one too?
Yeah.
So most of the time, most places, the light didn't seem to change, but there were some places where it seemed like the intensity changed, right? All right. If you have iPad, same way? Oh, yeah.
In the lab.
Yeah.
If you get up close, different colors, it'll be purple and green, blue, goes through the
Yeah, good observation. So if you haven't already summarized that on step 1, make sure you got that written down. And then we're going to go to step number 2. Step number 2 requires 2 filters. Okay? So this time you're going to hold one of them close to the light source, the other one close to your eye. And we're going to rotate, let's see, which one's the second one?
between your eyes and the fixed filter.
One and a fixed
the one
filter.
closer to you.
Oh, so the second one's close to your eye. So you're going to
You
hold
on the screen.
the one in my left hand and look at something, and then rotate the one in my right hand and see if you see anything going on.
So
Makes that whole second one go black.
That's awesome.
that one's white. If you keep
Oh,
on
that's-
then that one's
I made you appear.
Oh my
No, we
god.
It's just polarized lenses, so if you have like sunglasses, they do the same thing.
What the?
All right, I will wait while you summarize your observations under question number 2, where it says, what happened to the intensity of the light as you rotate the filter?
Okay, so, that part of the tape, 100% down. There's
Is this kind of like whenever you're running lines in parallel or in series? Like, because pretty much no light's coming through. If you rotate them at some point, wouldn't it seem like there's even more light coming through than just one alone?
The way I'm thinking, I'm not understanding exactly what you're saying, but for me, it's not like an electrical parallel
Like when we were
series
talking about
circuit type thing.
resistance, I'm not thinking like resistance whenever, like if you have resistance, if it's in parallel,
Oh,
the resistance,
I'm going to
resistivity
put
is
you off for
even
a little
lower.
bit, because you're going to see something in a few minutes that will have an impact on your decision on that.
Okay.
I kind of saw that
Let
too,
me
but I
go here
got.
first.
So if I have this right.
Usually that's done electronically now, it's digitally, but yeah, you could do that. I mean, before the digital age, yeah, that would have been a logical way to do a fade. Yes. All right. For step number 3. Oh, I'm sorry. Go ahead, Scott.
Yeah, like, I don't know if you want me to make this observation yet, but I saw almost like a harmonic motion idea, like, if you think about resonance and where we have like, all constructive or all destructive, what was it? Adding,
Yeah, constructive interference was resonance.
interference,
That
that's
was
the one,
always
yeah. Like, it seems like if you have it at one set, you can get it all destructive, and if you have another set, you can get all constructive.
What do you guys think about that one? He said that when they're in one orientation, you had all destructive interference, and in another orientation, you had all constructive interference.
So it gets brighter if you have it one way?
That's the part that the constructive interference is the one where I have an issue. The destructive interference, I can see that because it goes completely
Well, I'm
black.
not really saying, I'm
But
saying,
if it is constructive interference, then it would get brighter. And I don't think the two filters are ever brighter
well,
than
like,
the single one.
what I meant by constructive is just making because like I'm saying these both are a little bit destructive on their own, and that any constructive force that they would have would just make it go back to plain, like clear.
I understand, and I think we'll clarify